Hello and welcome, episode 3 of How to Design Web Services. We've already done 2 episodes, and if you are back here for the third, it means you aren't bored to death. Awesome, fantastic. Let's get started with some more of our points. So, in our list of 0 to 20, we are now on point number 2. The GET call. The GET call is one of the simplest. Usually the GET call is a web service call which takes a unique ID for a particular object, like get me this voucher's full details, or get me that bank account's full details, or this customer's full details. So it usually takes one ID and it gets all the attributes associated with that ID. The interesting point that I would like to add here, which is sometimes forgotten, is that the GET call should also support HTTP GET, not just HTTP POST, so that the ID and other unique index or unique identifier value can be passed in the URL itself. So if you look at this example, /app/voucher/1853. So this is a clickable URL. It doesn't need an AJAX call to be triggered through JavaScript and passing some request parameters and then getting a response. If this can be triggered as a simple ordinary link, then without the intervention of JavaScript, you can embed this link in a web page or in other appropriate places, even in an email, and then the user can click on it. If he's authorized, he'll be able to get the data out. So it is good to have it's good to have the GET calls also enabled to receive their parameters from the URL rather than only from a post. That's all about the GET. Otherwise, we all understand what the GET call does. The next point that I wanted to draw your attention to is about the update web services. Now, in the update web services, almost all parameters are optional. So the only parameter which is mandatory is the unique ID. So if you are updating a particular object, you will have some way of referring to that unique ID by giving an object, right? Giving an object ID, by giving a unique ID, reference number, whatever it is, account number. So that is the only mandatory parameter to update calls. All the other parameters are optional. However, this doesn't mean that you can do an update call with just the mandatory ID parameter and nothing else. At least one of the optional parameters has to be provided so that that field's value can be updated. So only the ID is mandatory, but to be able to use the web service, you also have to provide at least one optional parameter. So the update call takes all the parameters other than the ID as optional. This means that the front end can make one update call and update one attribute, or can update 20 attributes in one call. That is the flexibility we wish to provide in the update web service design that we always do. So the update web service can take a variable number of parameters. Now, what is interesting often in complicated business applications is that there are often access controls per field. What this means is, I am allowed to update this particular field if the object is in this state, but I am not allowed to update the same field if the object is in a different state, and so on and so forth. So there are complicated business rules related to updating of fields, and those rules apply to per user, per field, and per status of the object. So all of these complicated rules need to be coded into the update web service. So the update web service can get a little hairy sometimes if there are all sorts of complex business rules. And sometimes updates are frozen, as in when an object is newly created, all the fields can be updated. When the object has been partly processed, then some of the fields cannot be updated anymore. For example, if I am creating a new bank account, the banking system may allow me to update all the fields in a freshly created bank account till the bank account is active. But once the bank account is active, certain things cannot be changed. The account holder's identity information cannot be changed, because then the bank account, the bank will have its own complicated process to re-verify the identity of the account holder before the bank account's holder information can be updated. So certain states of the object may partially freeze certain attributes. And then updates often have complicated cross validations. So if I am updating this field, it has to match with that field somewhere else, and there can be fairly complex logic in some business applications cases to allow an update to go through, because basically updates have a lot of if then else's and a lot of constraints and conditions quite often. Now, one should not confuse updating of ordinary attributes with updating of status. When an object status is being updated, very often it is in business applications where a particular object goes through a sequence of statuses and arrives at a certain final status. To give you one example, I am a member of this organization which trades in all sorts of goods, and I am issuing a purchase order. So a fresh purchase order is in a draft state. After somebody verifies it, it's in a verified state. Then after the purchase order is finally issued by the procurement department, it is in a issued state. After it has been issued, the order can be accepted by the vendor or rejected. So it can be in an accepted state or rejected state. Then when the order is fulfilled, it can get into the fulfilled state, and finally it can be in a archival or dead state. So a purchase order can go through many statuses. Now updating the status of the purchase order is never done using a normal update web service. So we usually have a separate web service called status update. The status update web service does a lot of things to move the object status from one status to the next, and these things are highly dependent on business logic and are not as simple as an update. We've already explained that the update operation itself may not be very simple. Status updates are usually much more complex. So this is about update calls. The next call, which is again very common, it's a very common member of the set of typical calls, is the delete call. We follow a rule that no deletes are hard deletes. In applications we build, we never physically delete a record from a table in the SQL database if the web service call is trying to do a delete. What we do is we always implement deletes using what is called the soft delete method, where we set a particular Boolean flag against the record. So there is an is deleted column, and that column type is Boolean, and the is deleted value is set to true. So that is how we do deletes, because business applications which we build for large enterprise clients usually have a lot of audit and compliance and traceability requirements. So if there is a physical delete required from the database table, we always try to do it by purging using a batch process later on, rather than deleting the record synchronously. So it's never deleted like that. We often need to provide MIS on deleted items. So sometimes what we do is we take the record, we move it from the main table to a deleted items table. So that is how delete is implemented. It is not physically deleted from the database, but it is physically deleted from that table, and in the same transaction, it is inserted into a deleted objects table. So that allows us to generate MIS on the deletion of objects and report on, which object was deleted, how many deletions happened today, how many happened yesterday, and so on and so forth. And deletions being a very tricky operation in terms of business transparency and tight corporate governance, data change logging is mandatory. So you anyway have to log all deletions somewhere or the other, so that you can retrieve full information about when, who, what, why deletion happened for any type of object. So deletion has to be done, implemented with care. The web service interface itself looks simple. You just pass an ID, and if you have the authorization, the object is deleted. But internally, the way the deletion is implemented has all these shades of gray and all these refinements, if I may say so. Now we are looking at a set of calls which are not core to the application per se. They are calls which are implemented to help you build a good front end. So these are what I am terming calls for assistance, to assist the front end. These are not web services which are implemented to perform some operations on the core data in the core database. These are operations which are performed to allow a front end to become more responsive. Let us look at some of these examples. Okay. First is autocomplete. When I'm typing an account number, or when I'm typing, let us say, a name of a branch, suppose an organization has hundreds of branches and I'm typing, let us say, CHENN. So there is a Chennai branch, or there are 5 Chennai branches. I would like to see a drop down immediately with the list of 5 Chennai branches, because those branches' addresses have matched CHEN, right? This is what we call autocomplete. So I have typed part of the string, the rest will be pulled out from the database, shown to me. I can simply select. I don't have to type the full name. Now autocomplete puts tremendous amount of I/O load on the database. So autocompletes are very essential for making a nice, friendly, responsive UI, but are also, they are also very difficult to implement if you implement them in a thoughtless manner. So it is important to implement autocomplete by using a separate database. So we prefer to implement autocomplete using a separate Elasticsearch database, which is basically not used for transactions. It is only used for quick searches based on string matching, where Elasticsearch shines, is very powerful. So autocomplete preferably should be implemented by having a replica of your tables in a separate Elasticsearch database, and the autocomplete should be a separate web service which queries the Elasticsearch database, pulls out the matching records. The second place where we need such assistance web services is for field level validations. Suppose there's a form with 20 fields. The user is entering field 1, field 2, field 3, etc., etc. When he finishes entering field 3 and goes to field 4, the UX may require the system to validate what he has just entered in field 3. So he's gone to field 4 and is entering data. You don't want to wait for him to enter all 25 fields. He's filled up field number 3. He's gone to field 4. Make a quick web service call to check the validity of field number 3. So this kind of an on-the-fly validation is done using separate web services, which are usually written to be very fast, to operate from cache if there is any caching layer, and which will just return a go, no go about the value entered in field number 3. So special web services may need to be written to enable a more responsive, more user-friendly UI. In another example, special web services to prefetch interesting data. For instance, I am filling data about, I don't know, maybe vouchers of a particular type. So I'm trying to enter a new voucher. I'm filling data about that voucher. And as I enter vouchers of a particular type, one of the accounts, one of the ledgers in the voucher is a particular bank account. So I am maybe going to enter a payment voucher, which will move money from my bank account into a vendor's account. So when I'm entering that payment voucher, I have just entered the account number ID of the account which I want to pay from, right? As soon as I do that, it will be nice if the system can pull out the data of the current balance in that account and show it to me on the side. So while I am entering the voucher is still half complete. I have just identified which is the account from which I will make the payment. The system in parallel probes the account's database, pulls out the account balance and shows it to me. Very nice. Now this kind of prefetching of interesting data requires separate web services. You can't do an account get to pull out all the data of an account. That will be too heavy. So you might want to have shorthand web services which pull out data like this. Then you might need web services for what I call full tree get calls. What's a full tree get? Okay. A get gets you an object. Imagine a database schema where account details are in an account table. That table has only one record per account. Now, each account is associated with an account holder. So there is an account holder table to which the account record refers. So there is an account holder. Now the account holder has a postal address. The postal address may not be kept in the same table as the account holder. So there might be a third table which is the postal address of the account holder. So if I wish to get 100% information about a bank account, I will first have to pull out the bank account record. Then I'll have to look up the account holder, go to the account holder table, pull out the account holder details. Then from there I will know that there is a reference to the postal address table, and I will pull out the postal address details of that account holder. So I might have to traverse 3 tables. This is called a tree traversal, a reference from parent to child, child to grandchild, and so on. Now if I need to do this very often, I might write a web service which will pull out the full tree in one call. So that's a full tree get call. The classic way of doing it would be very boring. I will do one get call for just the account, the second get call for just the account holder, the third get call for the postal address of the account holder. I will need 3 web services. Here what I'm talking about is that I write a special purpose web service because I know that my caller often wants the full tree. So to make it easy for my caller, I write a web service which will drill down through the tree, traverse the tree, pull out all the information, create a large JSON data structure and return it. So you might need web services for this. So as a web service designer, think about situations where adding these web services helps the application. Most of these calls for assistance are cacheable. So if the front end chooses to cache the result, that might be a good idea. So frequent lookups may be avoidable. So these are just thoughts about where you can use these web services. Okay. So that brings us to the end of episode 3, and we will soon be taking you to the next episode, episode 4, where we'll be traversing a few more interesting ideas. Thank you for joining us, and have fun.